every single day, thousands of people are wheeled into operating rooms and put under general anesthesia. And we literally turn their consciousness off, perform a complex surgery, and then just turn it back on.
Right.
But if you walk up to an anesthesiologist and ask them exactly where in the biological machine that off switch is actually located, they can't tell you.
No, they genuinely can't. I mean, they know the chemical binds to certain proteins, sure, but the actual localized switch for the experience of being you, it remains a total black box.
Yeah.
Like, we can reverse engineer a smartphone, point to a specific silicon chip and say, you know, that part stores the data and that part does the math. But if you point to a neuron, you will not find the physical seat of human awareness.
Which is wild to think about.
And
And that's exactly why we are pulling from an incredibly wild stack of sources today for this deep dive to try and map that black box.
we really are.
Yeah, we have dense quantum physics papers, a neurobiology master's thesis by Miriam Osinga, a famously brutal critique by philosopher Patricia Churchland, and a really fascinating 2024 YouTube documentary transcript from a channel called Universe Unfold.
It's a great mix of materials.
It is, and all of these sources are orbiting one massive kind of paradigm-shifting idea. What if the brain isn't a biological computer at all? Like, what if it's a quantum computer?
Well, to see how we even get to quantum computers in the brain, we really have to look at this unexpected 1990s team-up between Sir Roger Penrose, who is a legendary physicist, and Stuart Hameroff, an anesthesiologist.
Right.
Penrose was looking at this from the physics side, and he was heavily frustrated with the standard Copenhagen interpretation of quantum mechanics.
Okay, this is the famous measurement problem, right? Where a particle can exist in multiple states or locations at once, a superposition, but the second a human observer looks at it, it suddenly just collapses into a single reality. Which, I've always struggled with that concept. Like, why would human observation have magical powers over the physical fabric of reality?
Well, Penrose struggled with it too. I mean, he found it mathematically and philosophically unsatisfying, that reality essentially required us to look at it to become solid.
Right, it feels a bit self-centered.
Yeah, exactly. So he proposed a different mechanism entirely, which he called objective reduction, or OR. He hypothesized that a superposition isn't just a mathematical probability, it is a literal physical separation in space-time itself.
Oh, wow.
Yeah. So when a tiny mass exists in two places at once, it actually creates a blister, or like a bubble, in the underlying geometry of space-time.
Okay, but blisters eventually pop.
Hmm.
You know, what pops this space-time blister if not a human observer?
Gravity. And this is Penrose's massive leap. As the superposition grows, the mass involved gets heavier, or the distance gets wider. And eventually, the curvature of space-time reaches a critical threshold where it just becomes mathematically unstable. The universe basically cannot tolerate the blister anymore, and gravity forces it to snap back into a single, definitive state.
And that's the objective reduction.
Yes. And Penrose theorized that this specific moment of gravitational collapse is a tiny moment of conscious experience.
Okay, wait, let's unpack this for a second. He's suggesting consciousness isn't a biological output at all, but rather the sound of a quantum space-time blister popping due to gravity.
That is essentially the idea, yeah.
But Penrose is a theoretical physicist, where in the wet, messy, gigantic human brain is this microscopic space-time geometry actually supposed to be happening.
And that is exactly the wall he hit. I mean, he had the physics, but he had no biology to back it up.
So he needed a brain guy.
Exactly. That is where Hameroff brought the missing puzzle piece. As an anesthesiologist, Hameroff suspected the secret to consciousness wasn't in the vast macro network of billions of neurons firing, but hidden deep inside the architecture of the neurons themselves, in these structures called microtubules.
Right. So for anyone listening and visualizing a brain cell right now, microtubules are these microscopic, crystal-like protein cylinders. They basically act as the scaffolding or the skeleton of the cell, giving it its shape.
Mm-hmm.
But I have to push back on Hameroff here, though. How on earth does a structural support beam do quantum math? I mean, it sounds crazy.
It does.
It's like finding out the wooden 2x4 studs holding up the drywall in your house are secretly mining cryptocurrency in the background.
That's a great way to put it, and it sounds completely absurd until you look at the mechanics of what those biological studs are actually made of.
Right.
Microtubules are not rigid pipes. They are constructed of individual peanut-shaped protein subunits called tubulins, and these tubulins can rapidly switch between two different shapes or conformations based entirely on the position of a single electron.
Oh, interesting. So they operate almost like microscopic logic gates, in a silicon computer chip? Like
Yeah.
flipping between a 1 and a 0?
Yes, exactly that, but with a quantum twist. Because it's an electron dictating the shape, and electrons routinely exist in quantum superpositions, Hameroff proposed that the entire tubulin protein could be in a superposition of both shapes at the exact same time.
Meaning the physical, biological scaffolding of our brain is computing in multiple states simultaneously.
Yes. And that brings us to their joint theory, orchestrated objective reduction, or Orch-OR. The idea is the brain biologically orchestrates these quantum states within the microtubules. It tunes them and protects them.
Yeah.
The superpositions grow and build up across thousands of neurons, acting in perfect harmony.
Right, until they get too heavy for space-time to handle.
Exactly. Gravity forces the collapse. Snap. A moment of awareness, and a rapid, continuous sequence of these collapses, I'm talking millions of them cascading, creates what you experience as a continuous stream of consciousness.
Wow, I mean, it is a staggeringly beautiful idea.
Yeah.
But we do have to look at the massive pushback from the mainstream scientific community on this.
Absolutely.
Because for decades, this theory was viewed as totally fringe. The sources point to physicist Max Tegmark, who basically brought the math to completely dismantle Orch-OR.
Yeah, Tegmark attacked the physical environment of the brain. Because in physics, maintaining a delicate quantum superposition is notoriously difficult. If you look at the quantum computers being built by major tech companies today, they have to be super cooled to near absolute zero and perfectly isolated in vacuum.
Right, otherwise any stray particle or just a vibration bumping into it destroys the quantum state.
The decoherence problem.
Exactly. And the human brain is the exact opposite of a vacuum. It is a warm, wet, incredibly noisy environment swarming with thermal energy, blood flow, molecular collisions. It's basically like trying to build a delicate 10-story house of cards in the middle of a Category 5 hurricane.
That's spot on. And Tegmark calculated the exact decoherence rates for that biological hurricane. He showed that a quantum state in a neuron would collapse from thermal noise in roughly 10 to the negative 13 to 10 to the negative 20 seconds.
Okay, help me visualize that timescale in a practical way, because I can't even wrap my head around a number that small.
It is incomprehensibly fast. We're talking a trillionth of a second, or even far, far less.
Wow.
Meanwhile, the electrical firing of an actual neuron, the timescale at which observable brain activity operates, takes about 10 to the negative 3 seconds, a thousandth of a second.
So wait, the quantum state is destroyed billions of times faster than it takes for a neuron to fire even a single signal.
Yes.
So it's completely dead on arrival.
By the laws of classical physics, absolutely yes. The quantum states would be obliterated by thermal noise long before they could orchestrate a single thought, let alone influence human behavior. And the neurobiologists and philosophers piled on right alongside the physicists.
Yeah, the philosophers didn't hold back at all. I actually have to read this quote from the sources by Patricia Churchland because it is just scientifically brutal.
Oh, I know the one.
She dismissed the entire theory by saying, pixie dust in the synapses is about as explanatorily powerful as quantum coherence in the microtubules.
Ouch. But she captured the mainstream consensus perfectly there. Trying to explain one profound mystery consciousness by stapling it to another profound mystery, quantum mechanics, doesn't actually solve anything.
Right.
And later experimental data seemed to vindicate her entirely. The sources detail a 2022 experiment at the Gran Sasso Underground Laboratory in Italy.
Okay. And they were looking for the actual radiation signature of Penrose's gravity-induced collapse, right? Like if space-time is constantly snapping back inside our heads, it should leave a physical footprint.
Exactly. And what the researchers found was that for a gravity-induced collapse to occur at the speed necessary to match the pace of human thought, it would require 10 to the 23rd tubulin proteins acting together in perfect quantum harmony.
And let me guess, the biological math just doesn't add up.
Not even close. The entire human brain only contains about 10 to the 20 tubulins. They were off by 3 massive orders of magnitude. The physical capacity to trigger Penrose's gravity threshold simply wasn't there.
So the balance takeaway for anyone following this saga up to that point was pretty clear. The brain is a classical biological machine. No pixie dust, no space-time blisters, just electrical impulses and neurochemistry.
Case closed.
And here's where it gets really interesting, because just when Orch-OR seemed completely dead and buried by the math, the year 2024 arrived, and new experimental technology absolutely kicked the door wide open again.
Yeah, the summer of 2024 was a huge pivotal moment. The sources highlight this landmark experiment from the Institute for Quantum Optics and Quantum Information in Vienna. Researchers successfully maintained quantum entanglement in tubulin peptides, those same microtubule building blocks we've been discussing.
But wait, we just established that the brain's thermal hurricane destroys that instantly? How did they pull that off without freezing it?
That is the most astonishing part of the whole study. They maintained the entanglement at physiological temperatures.
You're kidding.
No, they didn't isolate it in a vacuum. They mirrored the warm, wet conditions of the brain.
How is that mechanically possible without decoherence just destroying the state immediately?
Well, the prevailing hypothesis emerging from this research is that microtubules aren't just dumb structural support. They might have actually evolved a highly sophisticated shielding mechanism. Yeah, the hydrophobic or water-repelling pockets inside the protein structures seem to create these localized, insulated zones, and those zones protect the delicate quantum states from thermal noise. The researchers found that the quantum entanglement lasted for unprecedented durations in these conditions.
Wow. Long enough to bridge that massive gap Tegmark pointed out.
Long enough by several orders of magnitude, the quantum information could theoretically survive the journey down the entire length of a neuron and influence the release of neurotransmitters at the synapse.
That's unbelievable.
It directly challenges the assumption that the brain is entirely classical. Nature seems to have found a way to engineer a stable quantum environment inside wet biology.
Which completely shifts the paradigm. But we have to talk about the December 2024 study, because that one pushes this from a biological breakthrough into straight-up science fiction territory.
Ah, yes, the post-mortem discovery.
Yeah.
So a team of researchers was studying the quantum properties of neural tissue using freshly extracted post-mortem samples. So tissue from an organism that had literally just died.
And what they found in those hours immediately following death, before the cellular structure really degraded, it completely breaks my understanding of biology. They detected coherent quantum oscillations in the microtubule networks, continuing completely independently of any external biological energy source.
Right. The biological hardware had shut down. There's no blood flow, no oxygen, no classical electrical firing. Yet the quantum system was attempting to preserve itself, just oscillating in the background.
Okay, I have to stop you here. The machine is completely dead. The metabolism's gone. But the quantum state is persisting.
Yes.
I mean, where does the music go when the instrument breaks? Are we looking at actual peer-reviewed evidence hinting at a soul? Does this suggest consciousness survives the death of the biological body?
Okay, this raises an incredibly heavy question, and we really must look at the explicit guardrails the researchers themselves put around this data.
Fair enough.
Because they used extremely cautious language and invited severe scientific criticism, they stressed that this does not definitively prove Orch-OR, and it is absolutely not a scientific proof of an afterlife. We just cannot make the leap from a lingering quantum state to saying your personality survives death.
Okay, so then what is the actual mechanism keeping it going?
That remains the real mystery. The leading thought is that the structural integrity of the microtubules temporarily traps residual quantum coherence before entropy completely takes over and destroys the tissue.
Got it.
But what it undeniably proves, though, is that our classical models of biology are incomplete. The biological brain is doing something at the subatomic level that no standard computer model can currently simulate.
I appreciate the restraint. I really do. But even if it's just lingering quantum noise, it forces us to completely rethink what consciousness actually is. If the brain is utilizing quantum geometry, if it's tapping into the literal fabric of space-time, where does that leave our understanding of what we are?
Well, it leads us directly into this philosophical framework known as cosmopsychism. This is where Penrose's hardcore physics intersects with metaphysics. If consciousness is generated by objective reduction by the collapse of space-time blisters at the Planck scale, which is the absolute smallest level of reality, then consciousness isn't something evolution just accidentally cooked up in a biological soup.
Right, meaning the brain isn't a factory assembling consciousness out of dead chemical reactions. It's more like an antenna.
A highly complex, biologically evolved receiver. Yes.
So when I'm experiencing the world, my brain is just tuning into a broadcast that has essentially been playing since the Big Bang.
That is the implication. The sources actually reference some coverage by Popular Mechanics discussing this in terms of holographic consciousness.
Oh, yeah.
In this model, you can think of your individual neurons, your biological hardware, as providing the specific notes. But the field-level quantum resonances of the universe itself create the symphony.
It's wild how much this cutting-edge physics mirrors ancient teachings. I mean, the Popular Mechanics piece points out that this idea that awareness is the fundamental ground of being, not just a biological byproduct, is remarkably similar to ancient Buddhist philosophies.
It really is.
They arrived at the exact same conclusion thousands of years ago through meditation, while we're doing it with particle accelerators and lasers in Vienna.
It is a profound convergence of disciplines, and it fundamentally reframes your relationship with your own existence. Every time you are actively making a choice, or feeling the warmth of the sun on your arm, or even just sitting silently in traffic, the mechanism allowing you to feel that might be the microscopic collapse of space-time within your cells.
You aren't just a biological machine reacting to stimuli. You are a localized focal point of the universe discovering itself. As the cosmos produces more complex biological antennas like your brain, it is able to produce richer, deeper experiences of itself.
Exactly. But before we wrap up, there is one last concept from our sources that we really need to touch on because it offers a completely different, almost dizzying angle on all of this.
Okay, lay it on me.
It comes from a paper by Jerome Bussmeyer discussing the many worlds, many minds theory proposed by Nevin and colleagues.
Oh man, this is the one that completely shattered my understanding of decision-making when I read it.
Yeah, it challenges Penrose's fundamental premise of the collapse. What if quantum superpositions in the brain's microtubules never actually collapse? What if gravity doesn't force a choice?
If the blister doesn't pop, what happens?
According to the many minds theory, reality simply splits. Every possible outcome of a superposition is experienced, but by different branching versions of your mind.
Let's ground this in reality for a second. Imagine you're walking home at night and you see a really ambiguous shadow moving in an alleyway.
Okay.
Your brain creates a superposition of possibilities. Is it a stray cat or is it a dangerous dog? Under Orch-OR, your brain computes, collapses on one answer, and you react. But under many minds,
your physical brain enters an entangled state with the environment, and the universe just fractures. One version of your mind lands in the universe where it's a cat, and you experience physical relief. Simultaneously, another version of your mind lands in the branching universe where it's a dog, and you experience fear.
so conscious experience isn't about the universe collapsing into a single definitive now. It's just the specific path you happen to be consciously tracking through an endlessly branching multiverse of your own making.
Right. It suggests that every time a quantum state is processed in your brain, you are continuously diverging into countless parallel realities.
I invite you to mull that over the next time you're agonizing over a difficult choice. Are you actually making a decision, or are you just fracturing the universe and sending different versions of yourself down every possible path?
It's a lot to think about.
It really brings us back to that initial idea. When you pop the back off a smartphone, you know exactly what you're looking at. But when we try to look inside the mechanics of the human mind, we might actually be staring at the blueprint of the cosmos.
The machine is infinitely more complex and deeply more connected to the fabric of reality than we ever imagined.
Until next time, keep diving deep.